Welcome back, everybody. We're looking at what should be a quick, hopefully just a retube of the Soldano Avenger amplifier. I think first Soldano on the channel. This is a older one, meaning pre-2018 buyout. These for a long time were made in Seattle until I think 2018 when they were sold, and Mike Soldano sold the company, and construction is now handled by whatever it's called, Boutique Amp Distribution, I think, who basically constructs a bunch of other amplifiers. I think Wampler pedals, Morgan amps, I think Friedman amps also. I believe they're down in Los Angeles. Some people may know better than me. This amp does go to 11, just so you know. For those of you that don't know, these Avenger amplifiers are basically the lead channel off the SLO 100. So no clean channel, just the heavy distortion style. These are really cool. I've actually worked on this amp once, maybe twice before. Belongs to a buddy. Yeah, one of the first amps I worked on for someone else, actually, I think was this guy. Long time ago, like 15 or 17 years ago or so. Yeah, so, and if you don't know, these are great amps, really amazing. They still, okay, this will get a little opinionated. They still make Soldano amps. Mike Soldano sold the company in, I think, 2018. And the reason that went around at the time was because the output transformers, for most of the run of these amps from the 90s, late 80s and 90s on, he was using DeYoung transformers for the output transformers that he swore was like the signature sound of these amps. And what I heard was that they weren't going to be making those transformers anymore. And so he basically said, I'm done, because I can't make them at the same quality. And so he sold the company, and now they're still making these amps. But, I don't know what that really means. So if you are looking for one, look for an older one. They are expensive. These are like $3,000 or $4,000 amps at this point because people know that, and they're rare. But really great amps all around. So we're going to take a look at this guy. It's hopefully just needs a retube. But these are rare enough that I figured it's worth showing you guys on the channel. And there's a chance there's a cracked solder joint or something, because the customer said palm mutes were given some ugly distortion. So that could either be power tubes are starting to go out or something like that, or tube socket's dirty. Something from the vibration of the palm mutes is causing that inconsistent sound. Let's flip this thing around and see what's going on in the back, and then we'll open it up. Okay, not too much to see back here. A couple fuses. Soldano Avenger. Speakers. Impedance. No effects loop. I'll check these fuses out, make sure they're the right size, and then I'll open this thing up and show you the chassis. Okay, so this is a bit interesting. Again, because of what I've heard about the DeYoung transformers being the reason that, or lack of their availability being the reason that Mike Soldano sold the company. These are mercury magnetic transformers listed as, let's see, this guy's a Soldano 0100B and then a 100X, and looks like a 01B over here. So output and power transformer. Yeah, and I had heard that at least in the old days he had used this amp, maybe from before he started using the DeYoung transformers. And again, this is all just like internet stuff. Who knows? I mean, the guy had been building these amps forever. He also probably just wanted to do something else, or retire, or sell the company, or whatever. So take all of that, as always with internet speculation, especially in the music world, take it with a grain of salt. Just giving a quick wipe down here. And again, this guy is hopefully just coming in for a tube change. But we'll take a look. It is looking a little dusty. I am wondering if we have a dirty or cracked solder joint. If I remember correctly, this is all PCB, and these tube sockets are probably PCB mounted, at least for the preamps. So there's a good chance they might need a little touch up on the solder. Yeah, and if you don't know, with these SLO 100 amps, there's quite a bit of history about this circuit and how it relates between these amps, the 5150 amplifier, and you know, just that whole family of preamp circuit. It is kind of up for debate who stole what circuit from who. As far as I understand, the Soldano amps started out as modified JCM 800s, where, you know, the cold clipper resistor, and we can do a whole video going in depth about this. There's really great details all over the internet about this, but the cold clipper resistor value changing between the JCM 800 and what's in here. The resistor in these guys gives you a little bit more gain. I can't remember which way it goes. It's slightly lower value, I believe, like a 33K instead of a 68K or something like that. And again, we can go in depth about that. The Rob Robinette website has a really great walkthrough of the whole thing in terms of the difference in that circuit and the walkthrough of how that cold clipper circuit works to give you that asymmetrical clipping in one of the first gain stages of the JCM 800. But yeah, there is a lot of back and forth about, or there was at the time, about whether the 5150 borrowed too much in a legal sense of this circuit that's in these amps. Enough chatting. Let's flip this thing over, take a look inside, see what's going on. Okay, so here we are. Caps are looking fine, no bulging. I don't know if this guy's ever had a recap. Stock or mercury magnetic choke also, which implies it's not like these were changed out at some point. Now that's interesting. There's a screen resistor there, probably. Yeah, 500 ohm that's been changed out. These are probably the stock guys, 3 watts. Let's take a look. Take some just kind of basic measurements going through here. First of all, make sure that we don't have any voltage. Now, with this guy being a painted chassis, you can't get a ground point from just going to the chassis. We need to either go into like the screw hole. Now, I think we could probably go right there. But usually, you know, you want to verify that you have a good chassis point. So there's a back plate here for the back of the pots to ground by touching that back plate. But you can touch to the inside of one of the screw holes. I don't know if you can see what I'm doing there from the mounting point, because that would be worn away where there's no paint. So I'm just checking here to see if there's continuity between these things. But like, see on this, on the chassis, there's none because it is powder coated. But these screws hold on the transformer. Anything that's going through the chassis itself is probably going to have that connection. Otherwise, here's our earth ground, the green wires here. Okay, so let's see if we have any voltage anywhere. And I'm definitely going to touch up these tube sockets. This guy especially is looking a little toasty. Okay, 16 volts in the amp, look at that. So again, I'm touching pin 1. Somebody was just asking about this on one of the other videos. So if you happen to now be watching this video, I do have a video about discharging voltage in amps and how to check, or my preferred way for checking voltage. But you can see right there between chassis ground and pin 1. So pin 1 and pin 6 are going to be your plates. 1, 2, 3, 4, 5, 6. 16 volts there as well. Now what we can do, this is my favorite way to discharge voltage. We're going to, with our meter that's fused go to DC amps. I'm going to touch the ground point here, and then I can go to pin 1 or pin 6, and we can see that current discharge is a DC milliamperage. Now, may even want to go to microamps if we want to actually see it on the meter. And by doing it this way, oh, it'll help if I actually connect the meter correctly. My plug was on the volts still instead of the milliamps there, in case I was unclear. Okay, there we go. Now by doing it this way, we actually slow down the current because there's a plate resistor in between this node and our voltage source, which is the capacitors, where the stored energy is. So you're much less likely to get an arc from touching one of these things. Sometimes if you just do a direct short from like your filter caps to the chassis ground, you oftentimes will get a little spark. And it's very unlikely that'll hurt anything, but it can make you jump a little bit, which when you have live voltage in an amplifier or a device, you don't want to spook yourself too much. So we're just going to wait for this to dissipate all the way. It's probably safe as is, but just, why not? We're here. We'll just watch the microamperage. 18 microamps. That's real low in terms of voltage. Whatever's left there. And while we're checking this out, I'll just give you a quick update. Have been moving into the shop. Not quite fully set up down there yet, so still doing the amp work out of the garage for the next, hopefully just this one last week. But coincidentally, right when we got that shop and we're getting settled to move in, had a couple vacations planned, and then also had like no amp work over the summer, and now have like a 2-month backlog. So we getting lots of amps on the channel. Some of the personal projects will probably have to be on hold for a little bit. But that's okay. I'll try to squeeze them in where I can, or just work some extra days. Next up is going to be jumping back into that Fender Deluxe Reverb refurbishment. I've been working on that in the background, but the video is not quite ready yet. Okay, let's check our voltage. Going back to DC volts. And let's see what we got here. Oh yeah, nothing. Okay. Oh, so back to what I was originally going to do. Now that there's no voltage, we can get accurate and safe voltage readings. Let's go ahead and check out some resistors here. Make sure these are all good. These guys are 500 ohm. 470 is kind of a typical value for like a Fender style circuit. Now it's funny, in a 5150, we've talked about this before, but the stock is 100 ohms there. Marshall is usually like 1500. 2.2. These are our grid leak resistors most likely. And then we have some 1 ohm or like 0 ohm resistors right here. Yeah. So these are for bias measurements typically. Wonder, which is interesting because we don't have the bias point there. So those could just be being used as almost like a fuse for the cathode. Or if there's too much current, it'll blow a really cheap resistor. Also forgot to verify it with you guys, but the fuses did check out on the back. I'm just going to go through and double check. There's not a ton going on in these amps, which is really nice. So can kind of just check some things out. This is our bias circuit here. We've got a variable resistor, a potentiometer there. Easy to identify not only because of this, but because we have a single diode here for helping create that negative voltage. And go ahead and check that out. Check out our rectifier. We've got a solid state rectifier here. This is the kind of stuff you can check out without even having a schematic. Yeah, not much else to it. I probably, while I'm in here, will just touch up all these tube sockets just because they see a lot of heat and can desolder themselves. Tempted to fire this up with the old tubes just to see if I hear the problem that the customer is talking about, but I also might just go ahead and touch up the solder joints, change out the tubes, check the bias, clean the pots, tighten down the jacks, be on our way. Yeah, so I'll just do that stuff real quick. Here we go. Okay, so all the tubes actually tested good on the tester. Now again, with the type of tester I use, they can't definitively tell you a tube is good. It can tell you if a tube is bad to the point that it has catastrophically failed, but that's about it. So this customer has already bought new tubes. So I'm going to just go ahead and throw these in there, and then he will have his old tubes as a backup set. This is somebody that knows what type of tubes they like and plays a lot. So his request was new tubes. We're going to throw new tubes in. I am going to clean all these sockets, which is why I am showing you this process. Okay, so for this, people do this different ways. You know, some people like to spray directly into the socket or just spray directly onto the pins over the garbage can and then plug in and out. I'm going to kind of try to do, I'm using Deoxit D5. You could use whatever non-corrosive contact cleaner you prefer. I'm going to try to just dribble a little bit on here so I'm not making a huge mess. Gone back and forth on the best way to do this. There have been times when I've just blasted the tube sockets and then cleaned up any residue. Now this tube socket is a little loose, so I'm definitely going to, like at the board, resolder that junction. I would not be surprised if that's the actual issue we're having. Especially when you get problems that are like on a palm mute, when you're really rattling the amplifier. Now, this could just be the nature of these tube sockets. This guy kind of wiggles too. Yeah, when like if it's a really loud band or they're down tuned, or anything like that, there's always a higher likelihood that what's going on is there's a vibration-based problem with the amplifier. So either a cracked solder joint or something failing from that vibration that's occurring. Oh, this can of Deoxit is toast. Let's see if we got another one here. Oh, look at this. New can. Oh, it's got the optional flex tip. Or no, I don't. But I could order the optional flex tip. Wow. Look at that. Let's see if this just blasts. We do a test. Oh, yeah. It's going to be a blaster. Yeah, so whenever you have that kind of issue that it does consistently pop up with a vibration, look for cracked solder joints on your tube sockets, especially if they're board mounted. That's something that can easily happen. So, I'm going to switch to doing it over the garbage can because this new guy is a blaster. So I'm just spraying the pins themselves, giving a circular motion in and out of the tube socket. And we'll kind of wipe down the area, make sure we don't leave any residue. Now, if you do suspect something like that, where you have a vibration-based problem on an amplifier, one test that's really quick and easy that anyone can do is to take your guitar amplifier, take your head, assuming your speaker cable is long enough to do this, and set it on the ground next to the speaker cabinet, or even some distance away if you can. And that will help tell you, again, if it's an issue. Basically, removing your head. You can't do this with a combo amp, but with a head on a speaker cabinet, you can then reduce to basically nothing the amount of vibration that your head is seeing from those low notes. Which will tell you if it is a vibration-based problem. If you're at a point where you're feeling confident with your ability to work on amplifiers to the point that you can do tests on a live circuit, you can instead do a chopstick test, where you're basically poking the live circuit board to try to then create that same situation that you saw before. We're putting in some Tungsol 6L6 GC STRs. Again, this is what this person likes to play. These are great tubes. We're going to hook up the CompuBias here. When we fire this thing up, I am going to touch up the solder joints first, let all this dry, and then we'll check to see if there's any other issues. I've yet to try it. I need to experiment on one of my personal amps, but I know I've seen some people recently doing the same thing instead of using the Oxit, but instead just basically soaking the tube sockets in place with isopropyl alcohol and letting, I think that was on Psionic Audio's YouTube. And he seems to know what he's talking about, so might be worth giving a try. Okay. So again, we will in an effort to kind of let this stuff dry out before powering up the amp and checking the bias. Nice thing about those tubes is they're kind of short bottles, so can get away without using an amp stand. But yeah, let's go ahead and touch up these tube socket joints. I may check one other resistor here. What's this guy? Okay, yeah. This is a 10K resistor. It's a higher wattage. That's why it caught my eye there, 3 watt. That's probably helping drop the voltage between the screen and the plate nodes. Yeah, so that's going to pin 6. So this is dropping the voltage down lower for the preamp. Again, the things you can tell on an amplifier when you study these circuits, there's a lot. They're all basically the same, for the most part, with very few exceptions. So you can kind of look for patterns and look for things in a way where you don't need a schematic for basic troubleshooting. You really only start to need a schematic when you're getting into the weeds of something being pretty problematic. Can be very helpful in some situations, or if you're having to go through and change out a bunch of values, or if you need to order parts on a stock amp without opening it up. But as far as troubleshooting, there is a lot you can do by just looking at the amplifier. Okay. I would say too, okay, it's about time for a new soldering tip. I think I might even get a new soldering station for down at the new space. Being in new space, kind of have the temptation to get some new tools. A lot of these things I've been using for a very long time. Currently I'm using the Hacko 936 I've had for years, almost 20 years. But I also have a Hacko, what is that? The FX 888D. But, might be time to step up to something slightly more professional grade. Also, have been looking at some of the desoldering guns out there. Again, the Hacko, I think it's a FR301. I don't have much experience with those, but man, they look helpful. If anyone out there watching has used much of that stuff, let me know. I don't want to spend an outrageous amount of money, but don't mind investing in some new tools. Also probably going to get a fume extractor finally. So I don't have solder fumes. Again, the space I'm moving into is a shared space, so I don't really want to be blasting solder fumes into a space with someone else that might not like the smell of burning flux. Okay, so just being very conscious of not burning these wires. I am just going to touch up all these joints while I'm here. They all look a little bare. I'm not seeing any that are obviously cracked. But this is one of the failure points. One of the reasons that PCB mounted tube sockets are slightly less preferable is they're in a location where there's a ton of heat, so they can easily desolder themselves over time. But also, they're prone to cracking as well because of that heat, along with the vibration of the amp sitting on top of a speaker cabinet. This guy uses I think it's a 6x12. And they are in a location where if you get a cracked solder joint on a tube socket, you're going to end up hearing it. Because things are going to cut out and get weird. You're going to have problems. I'm also curious if anybody out there has played one of the new Soldanos and has experience with the original era ones like this. Curious what your experience has been. If there's a noticeable difference, if it's all just cork sniffing and really they're good quality. I try to not be too judgmental about amps until I see the build quality myself firsthand. But that sometimes is easier said than done. It's easy to form an opinion and a bias straight away, even when it is on internet speculation and rumors, rather than an informed decision based on firsthand experience. There, we hit this one. That joint doesn't look great. Okay, preamps. I might actually even suck the solder out of these. Some of these already have too much on them. Again, if we had a FR301 dedicated solder sucker, what a job this would be. In and out of here. This is the unfortunate truth of where amplifier repair tech wait times come from. This person comes in for a tube change and ends up with clean sockets and touched up solder joints on all their tube sockets. So I'm kind of making sure the tube socket is pushed all the way in here. As I'm doing this. Okay, so that's the one that was really suspicious. Let's see if the rest of these we can just give a little touch. No, I don't like that. So this time we're just going to do those first 5 and then get the other 4. Mostly so that on that first one I undid all of them, and yeah, this guy too, though. It felt like the tube socket was able to settle a little more than I liked outside of its position it should be in. Okay, halfway there. Just a quick tube change. As we get back into a routine of uploading videos here too, if there's anything specific you guys want to see as a more in-depth video, whether it's using a scope, instructions about, even though we've done it already, you know, somebody was just asking about discharging voltages. Happy to go through any of that stuff with you guys. Share my methods for doing things, talk about theory, talk about what I consider to be best practice methods, for construction or for troubleshooting or repair. This is one of those things that it's kind of a lost art, and I would rather not see it die. The more people that are into this stuff, the more likely we are to continue to have tube amplifiers for generations to come. So I want to be supportive of your endeavors in that world. This is the phase inverter. I have a history with this phase inverter tube. I think I mentioned it already, but this was one of the first amps I worked on for a friend years ago when I was first learning electronics. And was sharing a practice space with the guy that owns this amp. He asked me to take a look at it. He said it sounded normal, but it was very quiet. And again, I was still learning about this stuff. Tried everything that I knew how to do at the time. And what it was, this is a lesson I never forgot, but it was just a bad phase inverter tube. Don't know how I missed that. But because this is one of the points where usually if things sound good, but are just not as loud as they should be, there's a issue with the one of the amplification stages in the preamp. One of the gain stages. If things start to sound really muddy, especially loud volumes, but they are loud, then that's when we start looking at the power tubes. Really kind of a guideline more than a rule, but nevertheless. So this guy had to take this amp to the local expert who was not yet retired. And I learned a lesson about gain stages and phase inverters. And hung my head in shame. No, that's not true. That's how we learn. You're gonna make mistakes as you learn. With this or with anything. The trick is to learn from those mistakes and keep going. And hope that the mistakes are not too expensive. Okay. This looks okay. There's a lot of flux on some of those connections. I'm tempted to hit that with some isopropyl or something. I might do that off screen, but this video is getting long enough for a quick tube change. So probably we'll fire this up. Since I did resolder all these tube sockets, I'm going to put it on the current limiter first. And assuming everything is good, I'll give you a quick sound sample. If everything is bad, we'll dive into why. Be right back. All right, I've had the amp on for about a half hour now at this point. Bias is nice and stable. We're sitting at about 16, 17 watts. It's kind of jumping between 16.8 and about 17, which is within the range for the 6L6 GCs that are in here. Yeah, everything's sounding good. When I first powered it up, it kind of did a funny thing where the volume kind of stayed the same, but the gain wavered in and out real quick. But then I cycled all the knobs and it seems to have gone away. All the voltages check out. Everything seems good. I think we just maybe had a dirty volume pot or gain pot that wiggled out some dirt. None of the pots sound scratchy at all. Rechecked all voltages. If something like that consistently happens, it usually is like a capacitor going out. But everything seems very stable and it sounds killer. So I think we're going to call this guy good. Give you a little bit of sound here. That's kind of what these amps do. Again, you can pull the gain way back. But a nice out-of-tune guitar. But yeah, again, this is the dirty channel of the Slow 100. Great amplifier, simple to work on, built pretty dang well. If this is something you're looking for in terms of just having a good, solid gain tone, hard to beat one of these Soldano Avengers. Yeah, all right. Well, that's going to be it for this one. We'll see you on the next one. Thanks for watching, as always. And yeah, we'll get back to that Fender here in the next couple days and have that posted. Have a good night, everybody.